Hello and welcome to Graphing Quadratics video number 2. I have 3 examples I want to show you today, all a little bit different types for how these equations and graphs go together. In the first problem, we're given this function f of x equals 3 times x minus 2, x minus 6. And we are asked to give the x-intercept, the max or min, and the y-intercept. That's our directions. So when we attack it, the first thing to look for is the x-intercept. I know the x-intercept is the x values that make the value of the function equal to 0. So I can make the function equal to 0 and then figure out what x needs to be. I don't really want the 3 there. I can just divide the 3 away. It doesn't really affect anything. But let's just divide both sides by 3. Because 0 divided by 3 is still 0. So now I have 0 equals x minus 2 and x minus 6. By the zero product property, which states that if 2 things are multiplied together to equal 0, one thing or the other thing has to be 0, I can set both of these equal to 0. I know x minus 2 has to be 0, or x minus 6 has to be 0, so x has to be 2, or x has to be 6. And the way I write that for my x-intercepts then is x is 2 when the function is 0, and x is 6 when the function is 0. On my graph, I can go right here, 1, 2, 3, 4, 5, 6. Okay? Now the next part is I'm going to look to see if it has a maximum or a minimum. Looking at the first coefficient, this front number, the leading coefficient, it's positive, so that tells me it opens up, and it's a little bit bigger. It's bigger than 1, so that tells me it's going to be skinny. So I know it's going to be something that's up and skinny, and it's probably going to have a minimum down in here. I can find the x part of that minimum by looking at the middle of these 2 points, since all graphs are symmetric. I know that's going to be right here, which is at x equals 4. That's called my axis of symmetry. So I know it's going to be a minimum, and it's going to be for something. And the something I still need to find. I can find that something by plugging in 4 into my function and find, okay, what is the value of the function when x is 4? So I plug in 4 minus 2 and 4 minus 6. So that gives me 3 times 2 times negative 2, which is 6 times negative 2, which is negative 12. I think that's going to be off my graph. But when x is 4, y is negative 12, so that's 10, 11, 12. Let's just pretend my graph's a little bit bigger here. 11, 12. Okay, there is my minimum, and it's going to be coming up like this. It's going to be very skinny because the front number is 3. Now my y-intercept is probably going to be off the graph too. It's going to be really high up here. I can find that by letting the value of x be 0. I can see what is when x is 0, what's the height of the function. So f of 0 is 3 times 0 minus 2 and 0 minus 6. So f of 0 would be 3 times negative 2 times negative 6, which is negative 6 times negative 6, which is positive 36. Oh, wow. So this is way off the graph, which is okay. That happens sometimes. Our graphs are somewhat small. So when x is 0, y is 36. That's going to be way up here. Okay? So there's the first problem, and this is what the answer should look like here. Second problem, they give me information, and they say, write an equation that meets these conditions. If this is all I know about it, that there are x-intercepts at 4, 0 and negative 1, 0, and it opens up. And I have to write an equation. There's probably lots of right answers for this. But an x-intercept of 4 and negative 1 is going to be 1, 2, 3, 4, and negative 1, something like this. I can write a starting equation. I don't know what my front number is. I'll leave that as a. But I can write it as x minus 4 and x plus 1. And now if I could figure out a, I would be good. Now sometimes they give me a minimum. I know this one's going to be 1 something. If they gave me a minimum or a maximum, I could plug that in for x and f of x. Or if they gave me a y-intercept, I could plug that in. But in this one, they don't give me anything. So really, I just need any old equation that goes like this. So this one would be fine, or something fatter would be fine. or something really skinny would also be fine. Any of these would meet these particular conditions. So I could say that I know it's going to be a positive number because it opens up, but I could say 4, x minus 4, x minus 1. Here's a possible answer, and this is right. That would be very skinny. Or I could pick one that would be very fat and say 1/2 x minus 4, x plus 1. As long as my front number is positive, I've got the right answer. And as long as these represent the x-intercepts that I'm looking for. So that when 4 goes in here, it makes that 0. When -1 goes in here, it makes that 0. Okay, last one. Same kind of idea. They want me to write an equation, but there's only one x-intercept at -3, 0. That means this is what we call a double root, where the parabola comes down. It doesn't cross and recross. It just comes down and kind of kisses the graph and goes back up. And it has a y-intercept of 0, 18, so way up here. My graph is going to come down, and it's going to do something like this. And it's just going to touch and go back up. So if we have a double root here, then I need to write my equation as f of x, some number here. But when I write this, this will be x plus 3, so that -3 plus 3 makes this 0. Because this is a double root, and it doesn't cross and recross, this is the only roots, I need to square that part. So that I'm saying both of those roots are there. It's the same thing as if I said x plus 3 and x plus 3. But since I know that parabolas have 2 roots, I have to express them both in one point here. So it's x plus 3, or this. So then it's going to open up. That's what my y-intercept says. So again, any number here in the front will do. Let's decide to pick 2 for no particular reason. Oh, wait a second. Oh, wait. No, not any front number will do on this one. Mistake, Mr. Bibza. We've got a problem because they give me the y-intercept. That gives me some very specific information. It tells me that when the x value is 0, the value of the function is 18. So 18 can go here, 0 can go here. Aha, almost a huge mistake. So now I can figure out A. This is going to be 3 squared, which is 9. So if I divide by 9 on both sides, aha. See, A has to be, well, I randomly guessed 2 before, and it turns out I was actually right. So I was wrong, and then I was wrong about being wrong, so now does that make me wrong or does that make me right? I don't know. I think I'm probably just right. I'm just going to call myself right. So now I put the 2 in here, and then I have x plus 3 squared. Make sure that you put squared on it. That's the right answer after all of this. Have a great day.